We are team Nexo8_06. Today I'm gonna talk on my Smart India Hackathon 2025 project. Our problem statement ID is 25022. Our problem statement is maximizing section throughput using AI powered precise traffic control. Our theme is transportation and logistics. The PS category for the same is software. Our team ID is 74102. Our project, Maximizing Section Throughput Using AI-Powered Precise Control, focuses on revolutionizing railway traffic management through advanced artificial intelligence and operation research techniques. The aim is to enhance efficiency, safety, and punctuality while modernizing the Indian railway system. So let's not waste our time and let's move to next slide. Let's start with the detailed explanation of solution. Proposed solution system leverages operation research techniques combined with artificial intelligence to dynamically optimize train schedules and ensure conflict free operations by modeling operational constraint, prioritizing train movements, and enforcing railway rules. The system generates feasible and efficient schedules that maximize network throughput while minimizing overall travel time. Now, key feature is the system's ability to re-optimize schedules in real time, adapting rapidly to disruptions such as delays, incidents, or adverse weather conditions. This ensures continuity of operation and reduce cascading delays across the network. The platform also supports what if simulation and scenario analysis, enabling controllers to evaluate alternative strategies for routing, holding, or platform allocation before implementation. This proactive capability strengthens decision making and help prevent congestion bottlenecks. For usability, the system provides a controller-friendly interface that delivers clear recommendation, explanation for suggested actions, and the flexibility of manual override. Seamless integration with existing railway systems, including signaling, traffic management systems, timetables, and rolling stock databases is achieved through secure APIs, ensuring both smooth data exchange and operational harmony. By adopting AI based methods already proven by major railway operators worldwide, the system enhances capacity, punctuality, safety, and passenger satisfaction. Furthermore, it enables predictive and adaptive traffic management, setting the foundation for a smarter, more resistant railway network. Now, let's begin with uniqueness and innovation of a solution. The first uniqueness of a solution is controller focused device. The system is designed with a controller first approach, ensuring that operators have an intuitive, streamlined interface tailored to their need. The UI prioritizes clarity, accessibility, and ease of decision making, reducing cognitive load and enabling rapid response in dynamic environments. The second uniqueness and best innovation of a project is emphasis on transparency. Transparency is built into every aspect of the solution. The solution provides clear reasoning, explainability behind AI driven recommendation, ensuring that controllers can trust, verify, and override. Automated suggestion whenever necessary. For example, if anybody asks you to do any work, or for example, let's take our example for if a policy seller comes to you to sell his policy. If he directly asks you to sell policy, you won't be agree, you won't be buying his policy. But if he tells you why he is saying or why he is suggesting you, then you get a thought, yes, then you get convinced. So similarly, uh, we have the AI driven recommendation always ensures that controllers can trust them and verify them. This creates so overall this creates a balanced synergy between human expertise and machine intelligence. The third one is component recognition tracking. Leveraging advanced computer vision and AI models, the platform delivers real time recognition and tracking of components within the operational environment, from identifying critical assets to monitoring their status and movement. The system ensures complete visibility and control over essential infrastructure. The most important and the most innovative part of a project is AI powered real time hazard detection. The solution incorporates AI powered hazard detection mechanism capable of analyzing live data stream to identify anomalies, risk, or potential hazard. As they rise with proactive alerts and actionable insights, controllers are empowered to prevent disruptions, ensure safety, and maintain operational efficiency. Fifth one is human AI collaborative decision support. This system basically collaborates human and AI both for a total and for a smart decision making. So this was all of the detailed explanation of solution. Now let's move on to the next slide, which is of technical approach. The project will gather data from external data sources such as GPS tracker. The GPS tracker will track train movement in real time for ETA prediction, delays, and visualization on dashboard. Next comes the signaling system. The signaling system will ensure safety, manage track uses, enable AI, dynamically adjust schedule or reroute it. Next comes our timetable databases. From timetable databases, it will compare real-time data with planned data, detect delays or disruptions. Then comes weather APIs. Weather APIs will predict disruptions. Example, there will be a if in season of winter, it can be fog delays. Feed into an AI engine to dynamically reschedule or alerts. Now, this external data source will go through the real-time access data layer. What it will do? The first process it will do is data ingestion. Data ingestion will bring real-time data into your system from external sources. Example, API polling, WebSocket or MQTT clients, Kafka Connect or NIFI processes. Then comes data handling. Data handling, also known as message broker. This will decouple producer and consumers, AI, UI, etc., and stream data efficiently. Data routing. Data routing to consumer. It will send the processed real-time data to different part of the system. Now, from real-time data access layer or data routing, it will go through our smart brain, the heart of our project. AI optimization engine, which is called as a smart, where the data will be pre-processed. Data pre-processing. It will clean and normalize incoming real-time data and static data like GPS, weather, signals, etc. And also ensure data consistency before feeding into AI models. Then our smart brain will also have a delay prediction module. This delay prediction module will use ML models to predict future train delays based on real time position, speed, weather, and past delay patterns and help anticipate cascading delays. Then comes our schedule optimizer. The schedule optimizer will automatically adjust train schedules to minimize overall delays and avoid platform or train conflicts and optimize based on constraints like signaling, platforms, and time windows. Next comes in the smart brain is disruption handling module. This module will detect and respond to disruptions. Example, signal failures, accidents, obstructions, and trigger backup plans or rerouting action based on predefined rule and AI decision. The next part will contain the next part of the smart brain is scenario simulation model. This model will allow operators to simulate what if situations, example, track block train cancelled, and predict system behavior and help make proactive decisions before applying charges. Now, from real-time data accesses layer. This will also go into predictive maintenance system. In predictive maintenance system, the data preprocessing and feature attraction layer will clean raw data, remove noise, extract useful features, example vibration frequency, crack size, temperature, peaks for analysis. Then next come is anomaly detection. This will use statically threshold or ML models like isolation forest, autoconcoders to detect abnormal behavior on early warning signals of failure. Alert triggering or reporting. This was this will generate real-time alerts if critical thresholds are crossed and send alerts to operators, dashboards, or notifications. Now, the data which has been done in our smart brain will be processed to notification and alert system. The notification and alert system will basically do event listener and alert triggering engine. This will do continuously monitor data streams and detect condition that requires alert. Example delay. If delay is greater than 10 minutes, component is greater than 100 degrees centigrade, and alert will be triggered based on dynamic rules. Channel selector or route. This will decide where the alert should go. Dashboard, mobile app push, email, SMS, or webhooks. This will decide where the message will go. Now comes the delivery system. This delivery system will actually send the alert to the selected channels and include retry, logic, and acknowledgement tracking, alert log, and audit trail. Store all alerts, timestamps, delivery result, acknowledgements, and user interaction for layer review or audit. Now, this will also go into audit trail and reporting system. This audit trail and reporting system again consists of various parts. So let's start with the first one, which is event logger. The event logger will capture all system events with timestamp, source, event type, and metadata. Events include predictions, alerts, failures, override, and external command responses. The user then comes the next part, which is user action tracker. Log all actions taken by user via UI, example override, a schedule trigger, a manual alert, reroute a train. Okay, so it will reroute a train. It will trigger a manual alert. Now comes data storage or logo DB. The data storage will store logs and events in a structured and curable format. Example Elasticsearch SQL time series DBs. Now comes dashboard visualization tools. This will show logs and reports on UI for monitoring and analytics and chart timelessness and filters drill downs. These all this audit trial reporting system is again will end, and this is again connected to our then our not then our AI optimization smart brain is again connected to the next part, which is our integration. Our integration rate again consists of many parts. The first part is command translator protocol adapt. The command translator or protocol adapt convert internal system decision into external system compatible forms. Example MQQTT to IEC 6439 modules. Reset API and ensures commands are readable and physical or legacy systems. The next part is execution interface. The execution interface will send instructions to external systems, train control system, signaling system, maintenance system. Now comes the third part, which is manual command executor. The manual command executor allow execution of operator triggered commands from the UI like scenarios, simulations, or emergency overrides. Now comes acknowledgement handler. Acknowledgement handler. This will wait for confirmation from external systems, example signal state change successfully, and handle retries and acceleration if needed. error handling, and log. Log any failed integration, raise alerts, and store integration states for auditing or reporting. Now, these all will be present on dashboard, which will extract inputs from all the blocks and display the result. The technology stack which we will be using in our app is TypeScript, React, Node.js, Fast API, TensorFlow, Kafka, Weather API, and Reactive with Python, Python with Pandas, and etc. Now, let's go on our next slide, which is of feasibility and viability of a project. The system leverages existing technologies, data availability, and AI libraries to ensure practicalities. Challenges such as data quality, integration complexity, safety, and real-time performance are addressed through fault-tolerant pipelines, modular APIs, user training, and rigorous safety certification. While initial investment is required, phased rollout and government support ensure long-term sustainability and ROI. Okay, so our feasibility, our project is feasible and also very viable. The dependencies of our project is computing hardwares, network infrastructure, third-party data providers, data privacy regulation, and historical data sets. The challenges. Challenges is data quality and availability. So for this, we have a solution like implementation of rigorous data validation and fault tolerant pipelines. I've told you earlier also. So let's go without wasting our time. Let's go on our next thing. Start with impact and benefits. So the impacts and benefit of our project is for the first impact. The first impact is for controllers, for trained controllers, which are their primary users. It will reduce stress, improve decision making, higher efficiency, and improvement through user-friendly tools. For passengers and freight customers. It will enhance punctuality, better capacity management, increase safety, and improve reliability. For Indian Railways, operational excellence, modernization, data driven oversight, revenue growth, reduced emissions, and sustainable infrastructure utilization. Social impact, job creation in technology and operations, climate friendly practices, and better services delivery for citizens. I would like to conclude that the AI traffic management solution by Nexovate Z underscore zero 06, a team which it will provide a scalable, innovative, and sustainable approach to transform the great Indian railways by combining AI, predictive analytics, and human AI collaboration. It is not only maximization section throughput, but also ensures safer, faster, and more reliable train operations. I would like to conclude by showing you our prototype. So first of all, when we will go to our website, it will ask for login. We will simply put our username, which is controller underscore XYZ, and we will enter a password. Then we will select our role. Either we are of controller, supervisor, admin. For all the three roles, our project will work on different bases. The three role, all the three admin role, controller or supervisor will have access to different types of our goal. Then after signing in, we first come our dashboard. On dashboard, it will show what is the punctuality, what is the average train delay, what is the throughput, what is the active incident. It will show live events like signal delay, train number 25580 arrived, or train number 12591 depart, like this, or if it will be critical, like this. Now it will also show the train positions, like which train is delayed, which train is where it is there, that it's this train is to New Delhi, this train is off to Banaras, this train is from Coimbatore, and it is critical in condition. It is also Coimbatore, Trenambo, and Pichu. Then comes our decision support. Our decision support will recommend that reroute train to 195 because it will reduce its delay by 5 minutes, and the confidence of it is also 94%. It will also help adjust schedule and also various type of there. It will also show you the performance and the system status. Now next come is alerts. There will be there will it will also generate various kind of alerts and notification as discussed earlier in our ppt, like it is very critical warning, what is the info, what is the total. Then come our schedule and timetables. It will come what is the current schedule, what is the timetable, how many active lines are there. I have taken example of very small time. As the I will be getting data, it will be increased by the time. Simulations. For peak hours we can have a simulation control, performance metrics, available scenarios, what is the available scenario, what are the recent results, how efficient it is, what are the recommendations and all. And at last, the last part, what is audit, where is the audit entry? Like I have done 1247 actions, how many active users are there, how many critical events have happened, what is the activity done in last 24 hours. And this is all will be done like this. All thing will come, what is the recent activity and all. And we can easily sign out from here and we can go to our page. So that was all about my project. I hope you like it and I deserve a like for this. Thank you.